The Center for Educational Media and the College of Education at Middle Tennessee State University are proud to offer professional development to K-12 educators in Tennessee through our online video library. These videos are aligned with standards set by the Tennessee Department of Education. For more professional development videos, check out our website at cem.mtsu.edu.
So this is kind of recapping what we talked about this morning, and I know most of you are not math. Maybe you've learned some math along the way or had some math clarified. Hopefully you've got some teaching strategies and ideas and some resources. But we stopped with univariate. Univariate, un is a prefix, means one. We had one data set. We had some temperatures we were looking at. The world does not revolve around one statistic, however. The world really revolves around relationships.
And even with that one, there were so many things to talk about. You had box plots, you had dot plots, you had the mean, the median, the mode, the first quartile, the second quartile, third quartile. Lots and lots of things that you can do. You can spend half a semester on univariate statistics if you really want to, and dig in and act like that miser that's running his fingers through coins. Just run your fingers through the data, analyze it 10 ways from Sunday, think of different ways to make deductions, okay? But we don't want to stick with one.
So you have this chart on the inside of your handout, if you want to annotate as we go.
Now fly in.
Yeah.
So if we want to do more, what the heading is bivariate. Bi means two, so that gets you started. What do you think you're going to do if you're going to switch from 1 to 2 in the world of number lines and graphic representation? You're going to move from a number line to what?
Cartesian.
Ooh. Ooh.
Yeah, we got it. Cartesian coordinate system.
Cartesian. That's a great history lesson right there about Descartes and the fly on the wall.
And there's a really great joke. Okay? And when you're doing dots, the dot plot on the number line, now what's the word in the Cartesian coordinate system?
Plot. Slope.
You get something plot.
S, SC, SCA.
Scatter plot.
Scatter plot.
Only took you 3 letters that time.
Yep. Scatter plot. So the dot plot moves into 2 dimensions. That becomes a scatter plot. And the purpose. Okay, now think a second. Let me warm this question up just a little bit. The purpose on the univariate model was to get one number that represented a series of numbers. We've already said we're in 2 variables. When you have 2 variables, what are you getting? What mathematical quantity are you working for?
Trying to get best fit line usually.
Location.
You want some location information.
I didn't hear what you said over here.
When you've got one,
I generally deal with best fit lines when I have scatter plots.
Best fit lines. Everybody heard of best fit?
and what is a line? It's an example of starts with F. Function.
Ooh, one
Okay.
letter.
So univariate statistics deal with single numbers. Bivariate statistics deal with functions. So you find functions to replace your data so that you can do predictions. So in univariate statistics, you're getting a single number to replace a collection of numbers. In bivariate statistics, you're getting a function, which is a relationship that represents 2 collections of data. 2 variables, what are they called? One starts with I.
Independent and dependent.
Independent and dependent. So you're not replacing a list of numbers with a single number, you're replacing a collection of pairs of numbers with a relationship between an independent and a dependent variable.
And this actually starts, the concept of function really begins in kindergarten with input and output. We don't formally call it that, but it blows up into middle school. By the time they get 6th grade, they're getting distance, rate, and time. They begin looking at relationships, and in 7th grade, they are full thrown into the idea of slope and independence and dependence, domain and range, and those relationships. The world in which we live is full of relationships, right? We model our world, whether it's the science aspect, whether it's the food aspect, whether it's health industries, whether it's agriculture, we model that with functions. So function-based mathematics is the foundation for middle school and high school.
Okay, so pass these along, and we are going to have a brief moment with a manipulative. And Tammy has the manipulative, and it is uncooked spaghetti. Okay, so you have 4 graphs that have scatter plots. We're going to look at 1, 2, 3, 4 in this order. So here's example 1. The question is, if we said we need a function, the simplest function in the world is a line. Now, I better hear a uniform answer to this question, okay? How many pieces of information do you need to write the equation of a line? 2. You need the tilt, called the slope, and you need where to put it up or down on the page, right? So that we use the intercept for. So what you're going to do is take the spaghetti for your line, and you're going to run it around until you think it fits that first data. So you're going to lay it down and tilt it on the page until you think it fits the data. You might even take, once you've got it where you want it, you might even take your pencil or pen and draw the line in using the spaghetti as your straight edge. You don't have to, but you can.
Now, if you look at your neighbor, did your neighbor place it exactly where you did? This is why statisticians usually graduate and make 6 figures starting out. It's also why with every statistics major there is a course called ethics. Remember Enron? Some of us that are old enough to remember Enron. You can take statistics and make anything happen. And there is an ethics involved in that. So as you're doing this in the classroom, if you're a math teacher, we used to actually talk about misleading statistics even in kindergarten and 1st grade. That's kind of left with the Common Core. But this is the perfect example. Look at your neighbor. Do they have theirs laying exactly the same way you have yours? Who has the better fit? How do you know?
And why did you put it where you put it?
So what was your
tell
thinking?
me, somebody tell us, what were you thinking? Why did you say that was a good line? What were you looking at?
I looked at that it went through the origin, its y-intercept, and it covered the most number of slots.
So if it goes through the origin, by definition, mathy, we're going to get a little mathy here. We don't apologize. That's what we're doing. That's why we're here. Anything that goes through the origin, we automatically call a what? D, DI, DIR, direct variation. That's where they begin in middle school. If it goes to the origin, it's a direct variation. What does a direct variation mean? If I turn the heat up in the winter, what happens to MTSU's electric bill? Versus if I turn the air down in the summer, what happens to the heating bill? It still goes up. That would be the indirect form, right?
They move in the same way, it's direct. If they move in opposite effects, it's indirect, okay? But I still need to know why you, even if you went through 2 points, how'd you pick which points?
Let me ask you, like I ask my students, how many of you tried to zap points? How many of you tried to catch the most points? Be honest, how many of you tried to catch the most points? That is what you are, I would give you red checks if you were in my classroom because you're honest. That is what most students do. They try to place the spaghetti to catch the most points. And this is where the rub comes in statistics. Do you always want to catch the most points?
So do you want a clock that's 10 minutes slow and is never right, or do you want a clock that's stopped and is right twice? Being right twice is catching points. right? You caught 2 points. If the clock is slow, it's 10 minutes, consistently 10 minutes slow. You can work with that. It's never right, but you can always fix it in your head. You'd rather have it telling time, even if it's a little off, than only being right twice a day.
Now, in a classroom, this would be a lesson that we would probably do over a day or two, so we wouldn't go straight to the punchline and say, you really don't want to catch the most points. The students would actually discover that, which they would do by the time they'd worked through some of this.
What you really want the line to do is to capture the input-output relationship, okay? So you want over the entire spread of data for it to be more right than not. In other words, you want the outputs of the line to be more like the dots. Which variable, another group answer, which variable controls the output? The Y. The output is the Y. And the Y, is it up, down, or left, right? Up, down. So you're wanting the up-down problem to be the least.
So let me just, because I heard some of you, she used the word controls, not in the meaning of what you all were thinking, which one is responsible for the output. Yes, the input is responsible for the output. That's what makes it a function. She meant which of the variables aligns with the output or represents, okay? I wanted to make sure I heard that, y'all heard that what
So
you thought
now
was okay.
we will progress one slide forward. There's the line. Now, if you look at that carefully and squint, it doesn't actually go through the origin. It doesn't actually really go through any points. This is computer-generated, statistically defined line of best fit because, and this is where I wish I had a board and marker and I could do this kind of thing. If you look, although it doesn't go through any points, it's really, really close to 5 points. So the vertical distance from the point to the line, if you took all those little vertical distances and lined them up, it would be a little short amount of error. So on your spaghetti on your page, if you have your line there, what you're looking for is the vertical distance between the data point and the line, either above or below that data point.
And you actually can have students draw this. They can take their pencil and they can draw how far it is from the point to the line, just drop a perpendicular. And then they can actually take like a scrap piece of paper and just start graphing those and use it as a ruler that they're building. And then they can see the differences visually. So again, that makes that a really low floor kind of activity for some students to make it accessible and to help them build understanding, versus you can take it all the way to where we're going to go with a high ceiling.
So if you take your spaghetti that you thought was in the best place and you move it down 1/10 of an inch or 1/4 of an inch, all those vertical distances increase. They all get much bigger. And you don't care if they're above or below, you just want all those vertical line pieces to figure out what those are. And the longer they put tail to tail and add up to longer, that's the more error you've got. So you want to shrink that error. So let's look at it, the next example. Does that look like a line? Does that pattern look like a line to you? No, not really. To me, it looks kind of like a parabola, but that's just me. This is what scientists do. They get the data, they take the measurements, they throw it on a scatter plot because people see patterns, computers don't. They throw it on a scatter plot and say, what's that look like? I bet there's a theory that I can develop that will give me an equation. I think that's a parabola. I'm going to develop a theory around parabolas, and then they go looking for real reasons in real life to support their theory. Could be part of the sine curve. What are the reasons, the principles of biology and physics that would cause that to be which? How would you choose between the two? Okay? So if you force a line through that.
So has everybody got their line placed on that one? Because some of you didn't, so take a minute and place it.
Yeah, get your spaghetti on graph 2.
Knowing now that you're trying to grab and minimize distances.
You're trying to make the vertical distances shorter.
So she gave you a really hard one for the next one because it's like, how do I do that? Because some of those are so far away. Mean, Dr. Martin, what a data
what
set.
can you say? Comes naturally. So if you put a line through that, the point at 6, at the -6, that's way, way up above. That's a lot of error. The point at 4 is a little bit below. That's a little bit of error. The point at positive 6 is not much error at all. But you've got so many points below and so many points above that there's just a whole lot of error. If I use that line, I'm right twice a day. I'm not right, but just off a little bit.
So this is middle school. Middle school standard is to look at your data, to look at your scatter plot, and just understand, is it linear or is it nonlinear? So how would you describe this set of data? Definitely being nonlinear. So at the middle school level, that's as far as it goes.
Yeah. And if you see a pattern, like we see both ends are high error and both ends are but in the middle is low negative error, that means there is a model, you just haven't got the right one. Patterns in the error means you can make adjustments to the equation and get a better data. Random error means you probably did as good as you can. And the other thing is, do we really care that there's positive error and negative error? They don't cancel, they're still wrong. So what we do is we can't take the absolute value because of mathematical considerations.
And there's that word, I'm just going to put my 2 cents worth in. If I could eliminate one word from the human language, it would be canceling. Because as Dr. Martin just used it, she meant what operation?
I said the positive error and the negative error will cancel each other out.
So she meant additive inverses, right? But if you walk in a 3rd or 4th grade classroom and you hear the word cancel, what operation are they referring to? They're referring to division or multiplication by 1 in terms of simplifying fractions. So do you wonder why we get to high school and students don't know how to undo operations when they solve equations? Because they really never learned operations because we used words like canceling. And she's not going to get mad because she knows I pick on this with elementary and middle school teachers and high school teachers because it always annoys me. It really, we need to be precise with our language. And she did say positive or negative first. So that's why I wanted to bring that back around, because she said we have positive and negative, that's your additive inverses.
So if you're adding positive error and negative error and claiming that averages out to 0 error or neutralizes each other, that's not true. Error is still wrong. It doesn't matter if you erred too high or too low. So what we do is we square everything because we can't use absolute value because of later math considerations. So we square everything to make it positive. Hence, your least square regression may be a term that you hear referring to this process. Least squares
and we're going to get there. We're going to do this on the calculator in just a minute. So hang in there.
Yeah.
It'll make sense.
So example 3, that doesn't look very linear either. We're going to speed it up. You've already got your spaghetti laid down.
Have you got your spaghetti there?
Yeah. Oh, get your spaghetti laid down. That looks like the reason it's a problem is it's kind of fading out as you go to the right. It's leveling out.
So as you're talking to students, some questions to ask them. Do you have more points above your line or do you have more points below your line? To let them start thinking about, is your slope about 45 degrees or is your slope greater than 45 degrees? 45 degrees would be where? It would split, right? The axis in half.
Okay, so there's the line, and there's still a little bit of pattern, 2 above at the left side, 2 above at the right side, some below in the middle. That's going to be an exponential.
But how many of you placed the line so there were that many points below it? Very good. Most students do not do that. They still think they have to kind of like even it out. So that's the next thing they have to work about. Not trying to catch points and then not trying to even out so they think there has to be the same number of points on each side because of they think they can add those differences and they will just eliminate themselves. So that's one of the other misconceptions when you're dealing with scatter plots and lines of best fit.
So these first 3 examples are to tell you, number 1, what a line looks like when it goes close to the data, and to tell you, you don't have to do linear regression. You can do polynomial regression, you can do exponential regression. There's lots of regressions. The statistics information is all the same. The vertical error is called the residual. The model is the equation, and you're looking for the coefficients that make that slope. You're picking the slope and the intercept. Or on the polynomial.
And again, we're going to do this in just a minute, so it'll make sense.
Yeah.
Okay?
So there are lots of good data where you're looking for patterns, and I would draw this pattern as a curve coming down and then leveling off at the x-axis, and I would say, I'm not going to look for a line on that data. I'm going to look for an exponent equation, an exponential equation. So the last example, there's the exponential. You can't hardly see it because of the blue. That's what an exponential curve would look like. And you saw the previous one. The fourth example, is there a pattern there? That doesn't look like a function. That doesn't have a pattern. That's just a cloud. That's not anything you should go looking for functions for. So there are data sets where you just go, huh, there's no pattern. That's it. Okay? You can put a line through it, but look at all that vertical problem. All kinds of mistakes going vertically. So we want to do now is the idea
We're going to go to
is,
your 84. But my computer just told me it was
oh, it's dying.
getting ready
So
to
what we want to
need
do is,
gas.
this is why calculators are so good for promoting math and science. You don't have to hand do the calculations. If you were going to hand do the calculations on this error, you would take the top y value, the bottom y value, subtract, square that difference, add them all up, and then start doing some more stuff with them. And the calculator will do all that without absolute transparency. You'll never see, or opaqueness, whichever way you're thinking. You'll never see it happen, okay? It will do all the grubby details. You just have to know the instructions to put it in the calculator. So if we can put these data sets in the calculator, then we can have the calculator give us the slope and the intercept, and we understand what best fit means, we understand what the residual means, and then we can answer questions using the model, okay? So what TI very nicely did was, we got your handout, and this is one that's on the internet. Tammy, you want to describe for them?
So on your calculator, you now have a TI-84CE, which, like I said, most people in Tennessee have gone back to the TI-84 because it's kind of the embedded calculator of choice for the standardized testing. You are going to turn it on in the same place you normally do, the bottom left-hand corner, only the Inspire handheld is different. Notice the emulator. So if you're working with middle school or high school, the emulator is nice because when you noticed I pressed the button, what happened? It changed color, so visually I have a clue. If you look down and look up, you can see what I just pushed. So that's really nice for students. It also will keep a history of keystrokes. So I used to run those off and print them out for my special needs students, as well as students that just were challenged, and they put those in their technology appendix for their mathematician's notebook. So does everybody have theirs on? Thumbs up if your neighbor's is on, which means you have a screen that's probably like this. There's probably a cursor, because I think, Ashley, they cleared them before they got here. So there is a program that is loaded. Now, normally, I would give you data and we would put it in, but knowing the time constraints that we had, I wanted to preload some data for you. So do you see about one over and one down from the arrows where it says PRGM? I'm going to push program. Now, yours probably only has data, because I was actually doing something with some teachers not too long ago, and I did a what's the rule thing. So do you see, look up here and it's red. When you look on the emulator, you can see which button I pushed, it is red. And do you see data? Now, the please do this button on the calculator is the enter button. So 1 is black, which means it's highlighted. That's the one I want. So you have two options. You can either push 1, or you can say, please do this for me, and push enter. So either one will get you there. I'm just going to push enter. And then you should go to a home screen where you see program data, and there's a cursor blinking that is saying, what do you now want me to do? Everybody there? Thumbs up. When you're using technology, you got to make sure everybody's with you, okay? Is your program data left justified? There's nothing in front of it. It is up against the side of the screen. Because if there's anything in front of it, it's going to read English like we read English, left to right. And it's going to say, I don't know what that stuff is. It's going to give you an error message. Okay? So I'm going to say, yes, please do this for me. So what's the please do this button? So hit enter again. And notice there are 3 parts. We're only going to take the time to look at the first one to kind of bring this to fruition from what we just did physically. And like I'm saying, what we are doing now would take like a 2 or 3 day class time to just begin to tip the iceberg. Part 1 is what we want to look at. So part 1 by default, 1 should be highlighted in black, right? So please execute for me. What would be the button? Enter, R1. And notice nothing happened. It said done. And you're like, oh, okay, so that was real exciting. Now what? Now, Dr. Martin gave you the student handout. I just wanted you to have this in your hand so you could kind of see some of the things that are out there. Those of you that are science teachers, you need to check out education.ti.com as well. The link and the education.ti.com is on the back, under the resource down there. They are developing a lot of science activities as well as math activities. So for science, you need to check those out. We're now going to go play with the data for just a minute. So to show you where the data is, do you see the stat button that's 2 to the right of the green alpha? STAT, which probably stands for, isn't that beautiful the way that works? So when we push stat, we get this stuff. We get edit, we get calc, and we get test. What do you think calc is? That would be calculating. That's where you would go calculate 1 variable stats, 2 variable stats, whatever we're going to deal with. Edit is where we're going to look at the list. Okay? How many of y'all have ever used a TI-84 before? Okay, when you go to list, what do you normally see? Can you describe more fully? Think about and observe. Think in your mind's eye. What do you normally see when you go to list?
I think she said it.
What? Keep going. And what does it look like?
A chart.
Now, those of you that have not used this before are not going to be wowed, but those people that haven't used it should be. Again, I'm on 1. I'm going to go to enter. Most times your lists have L1, L2, L3, L4. You can put names into the list. So you actually can name lists for students. They can name them. You won't lose your other 6 lists. They're still there. You're just going to add a list and you're going to customize it and name it. So it will make sense to students. Okay? So do you see that we have bounce and height? We have miles per gallon versus weight of the car, and then we have newspapers versus years, I think it is. So we're just going to look at the bouncing and the height right now, which is on your data, and I'm going to walk you through the activity because of time constraints instead of you working through the activity on here.
So
okay?
what you would normally do is you would hand enter, hand type all the data in. We just asked TI to pre-place the data so that we didn't have to hand type it in with you guys.
Well, and this is an activity that literally was created by TI just for regression. So the skill was not to type it in. And do you know how many mistakes students make typing in data? So if I can preload, and we can do the rabbit problem, and I can give it to you, and then you give it to her while I'm giving it to you, and then all of a sudden in less than 5 minutes everybody in the classroom has it, or you can preload it as a teacher. It really helps save a lot of time for the students. So here's what we're going to look at. Now make note. What are the columns called, the first 2 columns?
Bounce and height.
Bounce and height. So let's think a minute. I've got a ball. I'm bouncing it, and it goes a certain height. Think about independence versus dependence. So just kind of hold that thought for a minute. Now, I'm going to go and watch what I'm going to do. I'm going to hit second. So do you see it's red? And nothing tells me that I've hit second. It's just red. And then I'm going to go to the 0. What is over the 0? Catalog. And a catalog is what? It's a place that I go to find things. So when I hit second catalog, I get this alphabetical list of all of the stuff that the little guy that lives in this computer can do for you. Okay? I want to turn on something very important that I have to do if I'm going to deal with stat, and if we don't do it, we're not going to get the waha hoo hoo moment, and you're going to go, I don't have it, why? I've got to turn diagnostics on. What is a diagnostic? A diagnostic is simply a what? Even simpler than that, T, TE, TES. It's a test. It's just a test. I'm just going to turn on the diagnostic so we can test my statistics, okay? You have some options. I tend to be lazy. So instead of scrolling all the way down to the D's, I'm going to cheat. I'm going to go alpha. And the alpha button was what color? And so do you see the D that's like 2 under it? See the little green D up there? If I hit alpha D, it will take me, let me go again. It will take me to the D's automatically. You may have to do it twice on yours.
You only have to do this once, turn the diagnostics on, and then they're on.
And then I'm going to arrow down until I see diagnostic. The other nice thing about the emulator, it slows you down. Whoops, I just went too far talking. So do you see diagnostic on versus diagnostic off? If your diagnostic is off, it will give you your one variable stats, it will give you your regression equation, but it will not give you correlation. And since we started with 6th grade, we're trying to end with high school and carry it through to regression, okay? So all I do, what do I do when I say, calculator, please do this for me? Hit enter to turn it on. Again, to the home screen. You really want diagnostic on? It's blinking at me. You really want me to do this? How do I say yes, please? Enter. It's done. Nothing tells me it's done. It's just there and it's done now. So now let's play with the data set. So remember, I want to calculate this regression line, right? Now, Dr. Martin had a bunch of data. We're going to look at bounce and height. We want to look at this data set, and if you look at the top, it will tell you that you have a ball is dropped from different heights. How does it rebound? So what do you think is dependent? What do you think is independent? Is the height of the drop what makes it rebound, or is it the rebound that makes it be the height? The bounce determines the height. So let's go to stat. And now we're going to go to the right to calculate. So is everybody on stat? I'm arrowing to the right. Do you see one variable stats? I could run one variable stats for any of those data sets. We could have run it for our temperature. You would get them all, including the mean. You don't get the mode, but you get the median, you get the quartiles, you get the range, the high and low. You'd get the sample deviation, all that stuff. We're running what? 2 variable stats, right? We've got a bounce and a height. And if we could have pulled a clean number set for something to deal with Guinness or fermentation, we would have, but those number sets are like 4 decimal places. They're awful. They're huge. So I hit enter. The height is actually the independent variable. How high I drop the ball from determines how far it rebounds. Physics, why? That's a physics problem, okay? So basically we're doing some physics here. Now, how do I get the X list? Let me show you, because right now you have an L1, don't you? You're like, well, she has, I have an L1. Where'd that come from? Let me show you where that came from. When you go right here, do you see the word list anywhere on your calculator? It's in blue over what? So since it's blue, guess what we have to do first? Second. So there's my button. If you want to see what I push, look up here, it's red. Second list. And do you see that you not only have your 6 list, but there's bounce, and there's height, and there's miles per gallon, and there's weight and all that stuff. See all that? So What is the D independent variable? Is it the height from which I'm bouncing, dropping it, or is it the bounce, the rebound? The height. So I want to scroll down to height, or I could just hit 8 and hit enter, and now height is there. How are you going to find bounce? How do you do? What's the same thing? Second list, and then you're going to hit, and I'm just going to hit 7 and be lazy. Now, in less than 2 minutes, you have learned how to set up and calculate a regression on your calculator.
Is it height and then bounce or bounce and then height?
The height is my independent variable. How high I drop the ball from determines how much it rebounds. Now, the ring was put in your nose because what list did I give you first?
The bounce.
And we all know, because all of our books always give the X list first, right? Not always. We have to determine.
Alphabetical.
Okay? So we have to think about independent and dependence. The frequency doesn't really matter, and I want to calculate. Oh, I did not do the right thing. Dr. Martin, you did not catch me. Well, we have 2 variable stats there. That's interesting. You've got some 2 variable stats there. That's not what we wanted. Oh gosh, I made a mistake. Guess what? Write them down, fill up your book. You'll have volumes by the end of the year. Let's go back to stat. Let's go back to calculate. I'm not calculating 2 variable stats. What am I wanting to calculate, Dr. Martin?
Linear regression.
Thank you, and I even said that,
I
and
thought
I
it was
didn't
in
do
both
it.
places.
Now, do you see linear regression? How many times do you see linear regression? Used to, the only linear regression was number 8. And that always bothered the bejeebers out of me until I taught my first stat and AP stat course. And then it was like, oh, that's why it's A plus BX, because that's what they use in statistics. However, in math, which one do we like better? Because that's our slope-intercept form, right? So you may use whichever one you want to. I would prefer, and I think your students would like number 4 better. Now we're going to get a different list. But you still have height and bounce in there, right? You still have height and bounce in there, correct? You didn't lose them. Now we don't worry about frequency. Now we want to go, would you like to actually see the line and see it graphed on the scatter plot to see how close it actually is? So let's tell it where we want it to put the line. And this one you're not going to know, because this is just one of those keys. Do you see the key VARS that is right under the arrows, VARS? If you push VARS, do you see anything that looks like y-axis, y-graphing, y equals there? Do you see y-VARS? So scroll to the right, and then Dr. Martin told you in algebra we all deal with what? Functions. So I went to VARS, I scrolled to the right, I'm going to use function, and let's just put it in our first equation. Now I calculate.
And that long list of numbers that you saw in that first thing, all of those were used, all of those different figures were used to get the
calculate
A and
this.
the B. So that's all the stuff the calculator was doing behind the scenes.
The little man in there did all those squares, he added them all up, he did the summations, he did all that work for you behind the scenes to give you this nice pretty screen. So what is the slope of my line?
0.6.
Almost 1, not quite, 0.6. What is the intercept? So in your mind's eye, can you kind of see how that's going to look? Can you air draw it? Air draw it. What would it look like if you air draw it? Slope of about 1, that's about cuts the in half, right? And then we've got this R squared and R stuff, Dr. Martin. You were talking about that. So what is this? That's a pretty good number.
Those are good numbers. We're going to talk about them just a little bit because we're getting short on time. But the R and the R squared, R is the correlation. That tells you, do those residuals represent a lot of error or very little error?
Now remember, residuals is that distance stuff, right?
The vertical stuff.
Okay.
You want it to be close to either +1 or -1.
+1 meaning the line is
looks like y equals x, it's
Going
direct
uphill?
variation,
And -1 meaning the line,
has a negative
Runs
slope,
downhill,
which is
negative
an
slope.
indirect variation.
okay?
But all you want is close to 100 right, so a 1. The r squared is the square of the r, and you can say that so many ways and mislead people that
Now,
we're just not going to worry about
in
the
the
r
real
squared.
world, how well do we want the line of fit to be? This is where the ethics and the statistics come in. This is why statisticians make the big bucks. Because everything in the world does not model this perfectly. Oh, if it would, but it doesn't, okay?
There is a very good trade book, speaking of trade books, called How to Lie with Statistics, and it points out all the different unethical things that you can do. It was written in the
She would have to tell
1950s
that, yes.
and never adapted. So it's kind of like tips and tricks, and you read it and you say, so it's a good discussion generating book. Why is this right and wrong? It's been in 15 repeat publications, so it's highly regarded. But it's all in 1950s language, and you wouldn't believe how much English writing has changed since 1950s. So it's a great book to bring in. It's very thin, maybe 75 pages.
Now, let's graph, and let's look at what you did with spaghetti on dot paper that she gave you graphed already versus what the calculator will do. I want to do not a y equals graph. That would get me my y equals, but I want to see that scatter plot. I want to see a stat plot. So do you see stat plot anywhere? Do you see the upper left-hand corner over the y equals? Stat plot is what color? So what do I have to hit first? So second, stat plot. Notice every one of my plots is off. Probably yours are too, right? But the one has a black on it, so I'm going to hit enter. So hit enter. And do you see how on is flashing? The black is over off. That means it's off. It's flashing on. Do you want me to turn this on for you, really? Yes, I do, please. What do I hit? So now, if you scroll down, we want the first one. The first one's a scatter plot. There's a scatter plot, there's a connected plot, there is what looks to be a bar graph, but it's really a histogram. There are two different box and whiskers, and then you have your piecewise function, your step plot. Again, I have this issue with I really don't want list one. What do I want? I want height. So where do I go get height? Where did we go? Second stat for list, and it was number 8. And then for list 2, second list 7. If we were in class, we would have a big discussion here about domain and range. Students would have to set their windows. ACT test domain and range through window grabs from calculators like the TI-84. We don't have that time, so I'm going to give you the back door. If you go to Zoom, do you see anything that looks like it might be statistics? So if you go to Zoom 9, it does all the math for you. It figures out what's about 10 above, what's about 10 below. It breaks them up into its nice little increments. And it does all of that for you that if you're teaching class, your students do it first by themselves. We would take a whole day just on Windows, but we don't have a whole day. Is that pretty linear? Is there much spread between the data? Is there a lot of distance between those points and the lines? Do you see why it's 0.99? So what does that mean? Is that a pretty good model? So if I have that ball and I want to predict how high it's going to rebound if I drop it from 100 feet, could I now use that model and get a pretty good prediction? So why do we use data? To prediction, to tell us about the world, to make sense of the world in which we live. So
for example, if you're bouncing the ball from a land rover that's up on Mars, a Mars rover, and you're trying to verify the gravity, the coefficient of gravity on Mars, you're going to be bouncing the balls a bunch, looking to see how they rebound, plug them into the formula, and see if the gravity on Mars pops out and is in actuality what you theoretically thought it was. So there would be an example of exactly using this data set for that. Now, I will hasten to add that the math was done 2 places. Our conversations about residuals, using the model and answering the questions, that was the math. And then the computer did the math behind the scenes, doing all the squares and the sums and stuff. Okay? The stuff where you learn to press the right buttons at the right time is what the price you pay for getting the calculator to do the math for you. That's not math. So be careful when you're teaching that you don't spend more time teaching calculator than you spend teaching math, which is your questioning, which is the hard part.
At the high school level in Tennessee, unless you're teaching a stat course, they don't manually calculate regression. It's doing a line of best fit through technology, and if you read your standard, it actually says line of regression with technology, but they have to know how to interpret it. So that's the piece there. Then in stat, they actually do that in standard deviation by hand, and it's an exercise in tedium. So again, when you're using trade books, and if you want to hang around a minute and look at some of those, and I will send you the trade book piece for the Lady Tasting Tea. We listed some websites that you might want to peruse.
There's one I have to show because hopefully you will get something with the next
well, let me do this and then we'll go back. The first 2 are some little games and things, right, that you found where they can guess the correlation and stuff. The third bullet is our tax dollars at work. Anybody know NAEP? Elementary knows NAEP, middle school and high school. Middle school should know NAEP. High school, NAEP is our nation's report card. They have data going back on me, and I'm over 60, so they have data back on me when I was in elementary school. We are a NAEP state. The Kids Zone is our tax dollars at work. It's all things statistics, probability. It's a cool site to check out. You can compare your schools. Your school data is up there. You can see the demographics of your data in your schools. It's a wonderful playground for your students to go to. The Merlot.
That's tax dollars at work too. That's a website of scientific and mathematical web resources, everything from apps to computer programs to OpenStack books. So there's one thing I wanted to mention about this. Here's another set of data. So go home, plug it into your 84, and look at all the questions you can answer and see if you can answer them still. Okay? This is about bankruptcies in the United States, and it's real data.
I will put the PowerPoint, the PDF of the PowerPoint in there, so all the hyperlinks will be active, and you can click all the hyperlinks and everything.
The correlation talks about whether or not you've got that cloud versus something that really is a line. And those websites that do the correlation, I just want to pull up the one where we're not being respectful of our next speaker's time, but I just got to pull up this one because I can't live without it. I can't do your iPad, Tammy. The second one.
I'm bilingual, she's not. Which one, the second one?
Second one. Okay, it's not displaying.
Oh, that's weird. Why did it just go off? They must have reset it back in the back. There it is.
There are 4 data sets. There are 4 correlation coefficients. Mix and match. And then it just regenerates data sets, regenerates correlation coefficients. And then the first one is they don't give you any mix and match, they make you guess. And then they go blah when you guess wrong. So to get an idea of what good correlation looks like, go on that website and run through a few of those. Okay?
Yeah, that's kind of weird. I don't know. They must have turned off mirroring back there.
Okay, so
have you got something you can take away and use in your classroom, whether it was math or not? Did you at least get a strategy or a resource?
on your sheet of note-taking paper, take the moment and write down 3 things for yourself that you want to come back to so that you will benefit from this later.
You have my email. If you want me to send you the resources, plus the infographics and all of that, make sure your name's on one of those email sheets, and I don't know where they went to, but I will make sure I collect them. If you have one in your hand, let me have it, and I'll make sure I take it. Thank you for letting us come. As always, what I tell teachers, please take what you learn and share it with those you teach. If you have any questions later, let me know. And thank you. We're going to take a quick 5-minute break before we move on.
All have a good day.